Hi everybody. So in this video, I'm going to show you how to find a type 1 and a type 2 error for a normal distribution. So we'll work through two examples and then we'll try an exam style question. And if you want to work along with me, you can download this PDF from my website. I'll leave a link below. So in our first example, we're told that the random variable y is distributed normally with a mean of 12.4 and a variance of 2.1 squared, and that a random sample of 50 observations of X is taken, and the sample mean is taken to be the test statistic. We're testing the null hypothesis that the mean equals 12.4 against the alternative hypothesis that the mean is greater than 12.4 using a 2.5% level of significance. We need to find the critical region, the probability of a type 1 error, and the probability of a type 2 error. So the first thing we need to do is we need to state our distribution for the sample mean. This will be y bar is distributed normally with, we're assuming the mean of 12.4 and a variance of the 2.1 squared over the sample size, which is 50. If you're not sure how to state this distribution for the sample mean, you should check out my video on the central limit theorem. And we'll sketch this distribution. So we know the mean is at 12.4, and because the alternative hypothesis is mu is greater than 12.4, we're looking at the single tail test to the right of a mean. So we need to find this value c, and this is our critical value. And the area of our critical region will be the same as the significance level of 2.5%. So then we need to find the probability of y being greater than or equal to this critical value, and this has to be less than 0.025, okay? And we can work this out using our calculators. If we go to home, we want distribution. Now, because we've been given this area and we want to work out the value c, we're going to choose inverse normal. We want the area to be 100, take away the 2.5%, so 0.975. The average will be the 12.4, and the standard deviation will be the square root of a variance, 2.1 squared divided by 50. And then we'll execute this, and we get C is equal to 12.982 to 3 decimal places. So this is the value that separates the critical region to the accepted region. So our critical region is when y is greater than or equal to 12.982. If we get any measurement equal or greater than this, we reject HO. So for part B, find the probability of a type 1 error. A type 1 error means we reject HO given that HO is true. So we must be in this critical region, and this must be our model. And we can see that this has a probability of 2.5%. So this will be the probability of a type 1 error, 2.5%. This is always the same as our significance level when we're dealing with a normal distribution. And for part C, find the probability of a type 2 error. Well, this is when we accept HO, so we must be to the left of a critical value in the accepted region, but this model must be false. And we're told here that the true mean is actually 12.9. So the way we write this is we want the probability of y being less than the 12.982. This means we accept HO, given that mu is actually 12.9. And we can work all of this out on a calculator. All we do, we go back to normal CD. We're changing our lower to be 3 standard deviations less than a mean, or anything less than that. I'm going to choose 0. The upper is 12.982, and mu, we've been told, is actually 12.9. But our standard deviation remains the same. We can execute that, and we get the probability of a type 2 error 0.609. Okay? Let's try another question involving a two-tailed test. So now we're told that the random variable x is distributed normally with a mean of mu and a variance of 1.85. We've had a random sample of 200 observations taken, and we're testing the sample mean. It's designed to test the null hypothesis, that mean is 2, against the alternative that it's not equal to 2, using a 10% level of significance. Again, we need to work out the critical region, probability of a type 1, and the probability of a type 2 error. So we'll go through the same process. We'll state the distribution for our sample mean. This is normally distributed. We're assuming the mean is 2, and the variance will be 1.85 over the sample size of 200. And I'm going to sketch this distribution. So our mean, we're assuming is 2, and because the alternative hypothesis is it's not equal to 2, this is two-tailed, where we're looking at C1 and C2. And these are our two critical values. The two tails will have a probability half of the significance level, so 0.05 for each of them. So the probability of x being less than or equal to C1 and the probability of x being greater than or equal to C2 must both be equal to 0.05. And we can work out each of these using the inverse normal. So we'll go back again, inverse normal. The area for C1 is 5%, mu is 2, and the standard deviation is the square root of 1.85 divided by the 200. And this will give us C1, I'll show on a diagram as 1.842. And then to work out C2, we'll change the area now to 0.95, and we get 2.158. So these are our critical values. So the critical region is when x is less than the 1.842 or x is greater than the 2.158. Okay? For part B, the probability of a type 1 error, well, we reject HO given that HO is true, so it must be in either of our critical regions. So a probability of a type 1 error will be the same as our significance level of 0.1. And then finally for part C, probability of a type 2 error. Well, this is where we accept HO, given that HO is false. So it must be outside of the critical regions. So we're looking at the probability of x being less than the 2.158, but greater than the 1.842, given that mu is actually 2.12. So if we go to our calculator and we go to normal CD, we can choose our lower as 1.842, our upper as 2.158, and mu to be 2.12. The standard deviation is the same, and we'll execute that. And we get a probability of a type 2 error to be 0.6517. Okay? How did you get on with that? Let's try one final question. Okay, so here we've got an exam style question. If you want to read through this question yourself and then give it a go, you need to find the critical region at the 5% significance level and the probability of a type 2 error. You can pause the video, and when you come back, we'll go through the solution. Okay, so welcome back if you had a go. So we'll say that the sample mean is x bar, and this is distributed normally with a mean of the 6.2 and a variance of a 0.8 squared divided by the sample size of 40. And then I'll sketch its distribution. I also need to state the hypothesis that HO mu is equal to 6.2, and the alternative hypothesis is that mu does not equal 6.2. Because we haven't been told in the question whether we're testing it's less or greater than, so we must be testing for both. This will make it a two-tailed test. We know the peak is at the expected value, 6.2. We'll label this critical value as C1 and this one as C2. And each of these critical regions will have an area half of that significance level, so 2.5%. So then we need to find the probability of x bar being less than C1 and the probability of x bar being greater than C2. Both will be equal to 2.5%. So if we go to our calculators, we'll choose inverse normal. We want the area to be 0.025 for C1. Mu is 6.2. And the standard deviation is the square root of 0.8 squared divided by 40. And this will give us C1 to be 5.952. If we go back, we'll change our area to be 0.975. We'll keep the rest the same. And we get C2 to be 6.448. So our critical region is when x bar is less than 5.952 and when x bar is greater than 6.448. And then for part B, to find the probability of a type 2 error, we must accept HO, so the probability of being inside the accepted region, so x must be less than the 6.448, but greater than the 5.952, given that mu is actually 5.98 hours. So we'll go back to our calculators. We'll choose normal CD. We want the lower to be 5.952, the upper 6.448, and we'll change mu to be 5.98. Standard deviation is the same, and we'll execute that. This will give us a probability of a type 2 error, 0.5875. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find it helpful, please like and subscribe, and you can download the full lesson and the PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link below.